a brief introduction of Dr. K.S. Manuvelu. Sir has done a PhD from Engineering Faculty of Indian Institute of Science, that is IISc, Bangalore, in the year 1995. And the topic is Intelligent Design Support for Management of Geostationary Orbit Spectrum Resources. Prior to which, he has done ME in Communication Systems from Anna University, Chennai, in the year 1972. He has about 50 years of experience in space industries, including working in Indian Space Research Organization, that is ISRO, for 25 years. Sir, we are very much privileged to have today to speak on this topic. Over to you from here. Thank you so much.
Thank you, sir. Thank you for the kind introduction. And so today's good evening, everybody. Today's topic is ITU radio regulations and new technology development. We all know that the International Telecommunication Union addresses all matters relating to telecommunication, but we also know that ITU is responsible for ITU radio regulations, which provides a backbone for the international regulatory mechanism. But also ITUR deals with radio frequency spectrum and satellite orbits. But the aim of this talk is to highlight the information that ITU works with the industry to define new technologies that will support tomorrow's requirements. So this is also a role played by ITU. Probably we try to highlight that information also in this talk. Now, as far as the topics to be covered in this session is, one is about a brief introduction about the ITU radio communication sector. Second is these highlights of ITU WRCs and WARCs, World Administrative Radio Conference and World Radio Conferences, and what are the achievements made in those conferences, especially during the period 1971 to 2019. Then we'll also talk about the next ITU World Radio Conference and its agenda briefly. Then we'll go to the information relating to the new services and applications and technology, which will be addressed by WRC3. But we'll try to take out those portions. WRC 23 is a very long agenda and issues. On space services, about 5 or 6 items are there. But we take about 3 items which may be of interest directly to space services, and also not only space services, it also will be of interest to the new technology developments. So that is how the talk is structured. And also I thank JanyuTech team for inviting me to make presentation. And I also my association with Dr. Subbarao, Vadan Technology Limited, and Mr. K. Narayanan, former director ISRO. I also recall their contributions, and I have been working with them very long time. Of course, I also want to clarify that any shortfalls in this paper, if any, are entirely due to me. Before going to the talk, I also want to give the web references, because ITU, radio communication sector, standardization, development sector, they are all very well planned and well organized activities. Therefore, I am giving the YouTube references, and also these references may be helpful to know more about it at your convenience. ITU radio communication basically standardization, and basically to me it addresses how to control the spectrum and ensure flexibility for future expansion and new technology development. This is one important aspect is addressed in the ITUR recommendation. This gives some kind of organization diagram for the ITU radio communication sector, and we see that the stakeholders need to follow up with ITUR activities at 3 or 4 levels. One is that we need to the world radio conferences, which are held every 4 years. Therefore, this conference is meant for review and revision of the ITU radio regulations. And here the countries and the concerned parties, they submit their proposals to the conference for discussion. And mostly the proposals of the countries are some kind of organized at regional level. For example, in India, we work with the APT, Asia Pacific Telecommunication Organization, for sending the proposal to the WRC. So that is one kind of interaction. The another kind of interaction is with the study groups, basically for regarding the studies on technical operation questions, especially ITU recommendation relating matters. Then third one is about the interaction with ITU-BR. ITU-BR is the BR means Radio Communication Bureau. It's a permanent office in the ITU radio communication sector, which is located in ITU headquarters, Geneva. And there with the specific requirements pertaining to individual countries or organizations for IT filing, follow-up on coordination, notification for the filing, as a specific requirement. Whereas the WRC and study group are all generic level interaction. This is the specific requirements of a particular country or company. For that, we have to go and talk to the Radio Communication Bureau. It's called ITU-BR. In the French abbreviation, it's the ITU-BR. For any follow-up on the filings and other related matters of a individual requirement, individual company's requirement. Otherwise, we have to interact with ITU-BR for the ITU seminar, workshop, and training program, because they periodically conduct this type of program for training the administration, training the people involved in the ITU, the work of ITU or the work of ITU. Now, we try to very briefly address the highlights of ITU World Radio Conferences and World Administrative Radio Conference and World Radio Conferences dealing with ITU RR on space matters between 1971 to 2019. Quickly we can see. But before that, we can see 2019 conference. This is a conference held in Egypt. It was held in 2019 in October-November time frame. More than 3,000 delegates participated from governments and various organizations and private sector companies from all over the world participated in the WRC 2019 conference. Apart from that, there will be also online participation. Also, it will be there. So there's a very large gathering, and when the people from the countries, government as well as the private sector participate in the ITU WRC. So this is about the view of the WRC conference in 2019. What they achieved actually? WRC 2019 identified a globally harmonized millimeter wave frequency band for international mobile telecommunication, that is IMT 2020, otherwise known as the 5G, and they identified the frequencies around the 24 gigahertz band, 37 gigahertz band, 45 gigahertz band, 47 gigahertz band, 66 gigahertz band. And what is the implication? It is opening up. It can open up a new applications for intelligent transport system, the smart cities, and also sustainable development, and allowing effective addressing the climate-related issues, improved healthcare, sustainable agriculture practices, greater energy efficiency. These are the new applications are possible by these allocations, especially in the 5G. These are all 5G type of activities. But when they do the WRC, it's always balanced. When they do new frequency, opening up the frequency band for these services, for the new services, they also ensure the existing services like Earth exploration satellite service, space research service, meteorological satellite service, radio astronomy service, they are all protected. Therefore, they also simultaneously adopt measures, regulatory measures for protection of the existing services and operations. So that is how they go about it. They are seeing the requirement of the expansion of IMT. They are given the millimeter wave band allocations. At the same time, they also ensure the existing services see that they are all protected. Then other conferences basically addressed the frequency conference 2003, 7, 12, 15, 19, they are all addressed basically IMT, that is cellular phone telephone requirements, the IMT frequency band, finding the way to additional allocations for the thing. And the WRC 23, we said we'll discuss a little bit after this. And what we see is ITU WRC support for worldwide frequency allocation for IMT, International Mobile Telecommunication. This is basically a cellular system. Today we have something like 8.6 billion mobile phone subscribers, and because of the ITU support for finding a worldwide frequency allocation, therefore the same cell phone can be put into use during the international roaming. So because and other considerations, we have a very large number of mobile phone subscription in the world. And as for the technology is concerned, we can see that 4TE and 4G and LTE and as well as 5G, they are more successful than the 3G or 3G. 2G is still their voice communication. They are still being used. But between 3G and 4G comparison, 4G is more successful and versatile. And India also considerable improvement in the internet connectivity. Number of internet subscribers in India is about 865 million. The very good progress has been made, mainly because of the mobile phone proliferation. Now we'll see that, but the same when we see this, but conventional satellite system did not make that much progress. That is what we are going to see in this slide. Satellite DTH subscribers is not no significant increase in the demand for satellite DTH, maybe declining also. Of course, Doordarshan is maintaining a good number of subscribers, about 40 million, but cable TV subscribers about 50 million, declining market. But DD uses the free dish. It is freely available for the public. And what is happening is OTT market share is increasing. OTT growth rate, they say, is about 40%. OTT, is an internet-based service. Some people are predicting that now we may be having more than 424 million OTT users. Therefore, a very large proliferation of OTT subscribers is happening in the country. Then another good thing is about 80% of the OTT users from Tier 2 and Tier 3 cities. So therefore, as a motivation to switch over to OTT, the fiber penetration must be also increasing. For example, recently Jio has announced Jio Air Fiber, which will help the fiber penetration and also the OTT subscription. Similarly, the VSAT service also. About 5 years back, we had something like 3 lakh of VSAT phones in the VSAT subscribers, but now that has decreased to something like 2.6 lakh. Therefore, there is a decline in the VSAT, mainly because of the several reasons, and that also will address try to address it. And there is a decline in the VSAT. There is a conventional satellite system is not growing. Conventional satellite system is not growing. We'll address that point. Now, we can see the telecom scenario in India. IMT access services play a predominant role in telecom industry. The 80% of the revenue also comes from the access services. The total telecom subscribers is about 1.1 or 1.2 billion. And total internet subscribers is 865 million, just now we saw. The LTE technology dominates. Optical fiber technology also dominates. Today, the world's 95% of the international communication is done through optical fiber circuits. But satellite DTH, we see no significant increase in our subscribers. Cable TV market also declining. That OTT users are increasing about 40%. Public mobile radio trunking services also declining, because all is because of the cellular phone expansion, cellular network expansion. Then satellite VSATs also declining. So it is already reported that 5G rollout fastest in India with the deployment of 2.7 lakh 5G sites within 9 months. So therefore, I just to take that the Indian trend is also world trend. So if you take, there are 2 things ITU conferences help. One is IMT. ITU WRC conferences is supported worldwide proliferation of cell phone based services. And as I said, it is now 8.6 billion phone subscribers worldwide. While cell phone and smart TVs and internet based OTT services are growing, satellite DTH, cable TV services are all declining. Conventional VSAT services are also declining. That means there is no ITU is not the mistake of ITU. This is just an observation. Conventional satellite services are not favored today. Whereas non-GSO satellite network, that is a new technology era. The ITU conference supported new space technologies, in particularly non-GSO satellite constellation based communication satellite services. As a consequence, already several global non-GSO commercial communication satellite systems are operational. Therefore, distinctly we see ITU supported a new technology like cellular phone based services and also non-GSO satellite services. And with this, we are having the next IT World Radio Conference, which is going to be held in the end of this year in Dubai. And let us briefly keep the scope of discussion in WRC 23. It is going to be held in Dubai, United Arab Emirates, November 20th November to 15th December 23. The agenda is usual. It's a 3-week conference, but agenda is very long, and but we can pick up the agenda items of interest. Basically, space services. The agenda item 1.2, basically what we are seeing here, again, the same situation. The frequency bands originally allocated for space services. These are all the frequency bands meant for space services, fixed satellite services, 3.3 to 3.4 gigahertz, 3.6 to 3.8 gigahertz, 6.4, 7.025 gigahertz, and around 7 gigahertz band. These are all the frequency bands allocated for fixed satellite services. Now, WRC 23 wants to consider these frequency bands for IMT. A lot of debate is going to be there because these are all the frequency bands for most of these frequency bands are meant for fixed satellite service, GSO-based services. India is having a lot of operations in this band, but now it is being considered. The same bands are being considered for take away the frequency band from fixed satellite service and give it to the IMT. Therefore, this will be addressed by WRC 23, but they will have a balanced approach. Second one is already the frequency band 12.75 to 13.25. The uplink band has been allocated for the fixed satellite service, and now they want to see that this band is, as of now, is not for aircraft and vessels communication with the geostation satellite. I mean, there are a lot of restrictions are there in use of these bands for aircraft and vessel communication, and that will be reviewed in the WRC 23 conference. What is happening is GSO is more favored for aircraft and maritime application communication rather than for the land applications or the fixed satellite service, conventional fixed satellite service application. Again, this agenda item 1.16 is actually meant for use of, again, Ka band for the non-geostationary satellite service, because they want, again, review the EPFD, probably relax it more in favor of non-GSO. That is going to be done in the WRC because non-GSO gets a lot of boost nowadays from the IT. Then agenda item 1.7 is about the inter-satellite links. Because non-GSO system is more useful, more versatile only with inter-satellite links. Therefore, they will consider new frequency bands for inter-satellite links. These are all going to happen in the WRC 23. Then consider the spectrum needs and potential new allocations for mobile satellite service for the future to narrowband, because narrowband we have at present only Outcom only is operating a narrowband system for the data communication. I think they want to identify more such frequency bands for the mobile satellite service. With this, we will go to the technology development. We try to identify what are the new technologies these IT conferences will introduce, or what are the new technology IT is addressing today. So one is the use of high altitude platform station as IMT base station, and of course this subject has been well studied in WRC 19 itself, but it has been included as agenda for allocation of frequency band below 2.7 gigahertz for the IMT. It's a new going to be a new thing. That is high altitude platform station at IMT base station. Then second agenda of interest is agenda item 1.6 suborbital vehicles. It is basically in the launch vehicle area. Regulatory provisions to facilitate radio communication for suborbital vehicles. It is a very involved subject. We'll address the outlines of this technology, which is called suborbital technology. Suborbital vehicle technology for the launch, space launch area. Third other item of interest is the ITU and 3GPP forum, evolving standard for integrated satellite system, in particular with LTE, 4G and 5G. This is an important subject. We just now saw the conventional satellite system are not growing because the scope of the conventional satellite system is limited. Basically, they are all proprietary technology based system. They are standalone system. Conventional satellite system or standalone system, proprietary technology based system. Therefore the VSAT equipment manufactured by Hughes system cannot work in Gillette network. Gillette VSAT network cannot work with the USAT network. Therefore, there is no standardization, and therefore, what is 3GP forum addressed it, evolving standards for integrated system, in particular integration with LTE system. So the LTE is a terrestrial component of IMT, and how satellite can be integrated with that. This is of interest to both ITU and 3GP forum. This also we will see this about this new technology, because to overcome the proprietary based conventional system to go for the integrated satellites. The WRC 19 resolves to invite the radio communication sector, study the spectrum needs for communication between stations onboard the suborbital vehicles and terrestrial stations, and also accommodated stations onboard suborbital vehicles, while avoiding the impact on conventional space launch vehicle. WRC 19 invites the International Civil Aviation Organization to participate in the studies and provide ITU the relevant technical character required for the studies called for to resolve to invite ITU or radio communication. Basically, ITU and ICO should work out how the airspace used by the conventional aircraft can be shared by the suborbital vehicle. That is a challenging task before ITU and ICOA. And then as far as SpaceX plans for developing suborbital vehicles, SpaceX is doing that. They can crew up to 100 people it may take, and interplanetary missions. And it all talks about 100 tons, 100 metric tons to 150 tons, and very large payload launch are discussed by the SpaceX, and there will be discussions in WRC3 to study the regulatory requirements for suborbital vehicle. Even the definition is missing. ITU needs to define suborbital vehicle or the suborbit. Suborbital vehicle need to be safely integrated into the airspace used by the conventional aircraft and minimize the disruption during the transition to and from controlled airspace. This is one of the challenging tasks before ICOO and ITU. So these are the various references I given. I shared the PPT slides, therefore it can be seen. With this, we go to the third item, that is the ITU and International Standards Body 3GPP, leading to new paradigm for satellite communications. Using 3GPP technology standards for the satellite communications. We said that the scope of satellite system can be expanded if it becomes standardized and integrated with the next generation access technology, that is 4G and 6G. 4G and 5G. This is a figure where these are the non-terrestrial network, apps, LEO, MEO, and GEO, and these systems will need to be integrated with the terrestrial component of IMT. And already there are two methods. One is integration. Already Starlink, OneWeb, O3B, Amazon, they are ability to communicate with the standard mobile phones. And these development tracks are emerging legacy system, and there are two methods are there. The release 617 and the 3GPP release 17 and 3GP release 18. And basically what we see here, satellite spot beam and sharing versus Earth. So this is one new technology, Earth fixed beam, because the leading to frequent mobility events such as handover between orbits, even for the stationary item. Therefore, Earth fixed beam is preferred for the satellite system, and for integration into for integration of the satellite non-geo satellite system with the terrestrial system, Earth fixed beams are preferred, and because shareable beam is too often because satellite is moving, the beam is not moving. More frequent mobility protocols need to be added. That can be reduced drastically if the Earth fixed beams are used. The Earth fixed beams are supported by the 3GPP and possible. These are the evolution of 3GPP standards for NTN. And this figure also explains transparent payload and regeneration payload. Transparent payload, the existing system, you should have an interface that is the next generation, that is 5G node B station, that is a base station. The interface with the gateway. Therefore, the mobility protocols can be addressed properly here. So, for conventional satellite system, require an interface with the gateway where the mobility base station or more or less is interfaced with the gateway. Whereas in the regeneration payload, the gateway, whatever is in the mobile station, that has been integrated in the other part of the satellite communication payload on board, and therefore the interface becomes simpler, and this can enable also a inter-satellite link, and therefore the regeneration payload can be accommodated. But this is purely a future, not the present. The present is only this is possible. Future new national system will be launched with the payload, with the regenerative payload. Therefore, with the ISL is possible, as well as the we can integration with the IMT, that is 5G network is possible. 5G core network is possible. So these are the aspects, and these are the really 17 of the 3GPP addresses issued. And of course, SES has done a lot of made progress. SES, the international satellite operator, SES is playing a leading role in satellite integration of its MEO satellite constellation called O3BM with terrestrial network. That is a technology for integration, and it has been developed by ESA, European Space Agency, and SES and Thales and other satellite vendors. They have participated in development of interface for the integration of satellite with 4G or 5G network. So that is going to be another important new technology. Probably ITU also will support along with the 3GPP for this new technology. So non-terrestrial network like satellite will become part of the 3GPP standard, establishing a strong foundation for direct communication between satellite, smartphone, and the mass market user requirement. ID radio communication also will study and come out with recommendation for standardization of satellite system for integration with 4G and 5G. So with this, I complete my session. I think I already exceeded 7 minutes. Thank you for listening, and I try to.
I just wanted to know whether this integration of the 5G or 3GPP and the satellite, how far it is actually implemented. I know that a lot of designing work or planning work is going on, but how far it is implemented or when it will be implemented?
Gillette has already demonstrated integration of the conventional satellite system. Conventional, that is whatever already we are having K-band satellites. How integration Gillette has already Gillette is a VSAT operator, VSAT vendor. He has demonstrated the integration of the GSO satellite and another one is SES is doing some kind of experiment. They are as of now they started already the experiment. I don't know the results, but SES is doing experiment over in Central America as well as Europe. They are evaluating both the technologies, their own SES O3BM power and the GSO technologies. They are integrating and then trying to evaluate which is the best. But SES is already some experimental thing is going on and using the SAT-5 interface. The SAT-5 is the interface to the one. I think India also has acquired the technology, and the IIT Madras has done some work in that area. IIT Madras has been entrusted with the responsibility of studying the satellite technology before. That is basically all the software related 5G is with ITU, IIT. I think SAT-5 also will be used. But Gillette has demonstrated, SES has demonstrated. But it is only conventional system. The regenerative payload yet to come. There is no satellite with the regenerative payload. There is no new satellite with a regenerative payload. That has to be done. Nobody has planned such a satellite as a but that is for the future. That is new. First one has to plan a satellite with a regenerative payload. That is incorporate all the mobility functions of the Node B new generation or LTE Node B base station in the spacecraft, and then such a satellite will have the capability to do the ISL also, and that is the future. That is as of now nobody. It's a new technology, but IT also studied up to the release 7 only in the recommendation. Release 18, 19 they have not. Release 18, 19 is yet to come. Release 18 also they have not addressed because ITU report is also as of now dated 2019 only. But I expect IT will take more interest depending upon others also. As of now, IT is taking a lot of interest in the high altitude platform as station as the base station. But similarly, they will also take interest in the integrated. Otherwise, satellite is not at all growing, mainly because it is a standalone system with the proprietary technology. And therefore, scope of growth is limited compared to mobile phones.
So one more question regarding the high altitude platform. When we can expect that service to start, maybe in India or in any other country also on a regular basis?
So Japan is in the forefront. Japan is in the forefront in the thing. There is a SoftBank, the investor and the technology promoter. He is supporting that. And Japan has been working on this technology for quite some time. And probably it has to come in Japan first. And then they have to, then it will come to the other countries. But Japan is one thing because at present Japan is in the forefront in pushing this technology, and in the IT forum also they are in the forefront in including the as agenda item and pursuing it. And the frequency allocation will be made because that maybe my consider it is somewhat easier because the frequency bands which have been allocated for IFT, same frequency bands need to be used by high altitude platform base stations. Therefore, it is with the operator to make it compatible. Therefore, frequency allocation may come. But what is the difficulty is about the station itself. We have seen that is 78 meter long and very huge thing. And balloon also very huge balloon, and even airship also they say very large object. Therefore, it cannot be managed that easily on the ground. But technology is the question. But already, what is happening? You know already. Balloon is being used for the spy network already. Therefore, similarly, that technology may be released for the civil application in the course of time. But already, countries are using it for balloons for spy network for monitoring and
correct.
communications. Therefore, that type of technology may come ultimately. But the NASA developed technology only being put into use now. That is called the aircraft thing. But I think SoftBank in Japan is now in the forefront. Release has been done, I think, but release 18 has addressed the regenerative payload requirement, but there is no satellite with the regenerative payload because that satellite has to come. So there are also a lot of discussions going on how to design that communication payload, incorporating the mobile base station features in the satellite. All software only. All are basically software supported systems. But it is a new thing. But they are conventional systems. They are demonstrated already. Gillette has demonstrated it, and SES for the SES O3BM they demonstrated some experiment going on. They are evaluating between GSO and non-GSO.